Hello, geometry students. I'm Miss Newman, and I'm going to be walking you through the June 2015 exam today. If you could or would like to follow us on YouTube, you can click the link at the bottom, and that way you can access all of our videos, whether it be just the end of this year for Regents review or beginning next year too in Algebra 2. We have full solutions and all lessons for all of the Algebra 2 Common Core things. So if you follow us, you can get that help easily next year if you need it. So we're going to start going through here. All of the exams, I'm hoping to get them all up before the end of May, so hopefully we'll have full solutions for you by the end of May before you really start studying for your Regents exam. Question number 1. Which object is formed when right triangle RST shown below is rotated around leg RS? So to the best of my drawing abilities, which you're going to have to bear with me for a few minutes, they're not going to be the best, I'm going to pretend that this is a line that I'm spinning around, right? This whole line. So I'm going to spin around that. And as soon as you say spin around, rotate it around, that's something circular. So I'm going to try to draw you a beautiful picture of what that might look like. So it'll look like that once it goes over to that side. And anything with a spin has a round base. So that looks like a cone. Well, let's see. Oh, choice 4. No big deal. All right, so then number 2. The vertices of triangle JKL have the coordinates of. Okay, great. Under which transformation is the image of J prime, K prime, L prime not congruent? So you have to think of what is not a congruence transformation. What comes to my brain immediately is a dilation. When it says not congruent, I'm thinking dilation. It's not dilation, it's dilation, okay? I'm thinking dilation. So now I'm going to just look at my choices. Translation, that's a congruence transformation. It doesn't change the size of the triangle. Counterclockwise rotation, again, you're just turning it around. It does not change the size of the triangle. A reflection over the x-axis, you're just taking something and you're flipping it. You're not changing the size. A dilation with a scale factor of 2 centered at the origin. That is not a congruence transformation. All right, then we've got a circle, a center of circle Q has coordinates 3, -2. If circle Q passes through 7, 1, what is the length of its diameter? I want you to circle diameter. This is always a tricky question here. All right, so we have a circle of center of 3, -2. We have a point 7, 1. That's going to be a radius, right? That's going to be R. Diameter, diameter is 2 radiuses. So I'm going to calculate the radius using the distance formula. So we know that the distance formula, I should write distance there, right? Distance formula equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Hello, radical sign. So my radius is equal to, it doesn't matter the order of the points, just be consistent. If this is going to be your first point, if that's going to be x1, y1, and this is x2, y2, just be consistent. So x2 is 7, x1 is 3 squared, plus y2 is 1 minus -2. Double negative, I'm hoping I don't insult your intelligence, is positive. So I'm actually just going to go right to my calculator and I'm going to type this whole crazy thing in. So down here should be my calculator. I'm not seeing it. Hold on. Okay, I found it. All right, so we're going to go to this calculator here. And I'm going to type that whole thing in. So square root, control, square root of, what did I say, parentheses, let's see, 7 minus 3 squared plus parentheses 1 plus 2, 1 plus 2 squared, enter. And we get a radius of 5, so that's excellent news. So I'm going to go back here. Oops, not that one. Okay, radius of 5. So R is equal to 5. Oh, I can't get my, there we go. Okay, it just wants me to write with an eraser right now. Okay, nope, it's not working. All right, I'm having technical difficulties. Well, the radius is 5, so that means that the diameter is 2 times 5. So the diameter is going to be 10. Maybe if I click like that. All right, it's just being sneaky right now. All right, so the diameter is 10, so choice 3. All right, I have my pen back now. I was having a hard time. In the diagram below, congruent figures. So we know we're going to use congruence transformations. 1, 2, and 3 are drawn. How are we getting, before I even look at the question here, to get from 1 to 2, it looks like just a translation. And to get from 2 to 3, it looks like it's a turn or a rotation, right? So it says, which sequences of transformations map figure 1 onto figure 2 and figure 2 onto figure 3? Oh, well, moving, just sliding around, right? Moving left, right, up, down, and not changing size is a translation. And then in order to get A prime all the way to A double prime, I actually have to turn that figure. It looks like a 90-degree rotation. So a translation followed by a rotation is choice 4. Oh, this is one of my favorite questions. As shown in the diagram below, the angle of elevation. So angle of elevation is made with the horizontal looking up. From a point on the ground to the top of the tree is 34 degrees. Great. If the point is 20 feet from the base of the tree, so this distance is 20, what is the height of the tree? I'm just going to call the height h. I know you like to use x all the time. You got to get over that. So I'm looking at this, and I know right away that this is a trigonometry question. So I have to decide which of the trig functions I need to use. And so I'm going to write out SOHCAHTOA. I think a lot of people use that. I know the opposite side. This is the opposite side. I want to know the opposite side. And I know the adjacent side. Okay? So O and H, it's not sine. A and H, it's not cosine. Opposite and adjacent, that's tangent. So tangent of 34 degrees is equal to the height of the tree over 20. If you called it x, that's fine. Now, in order to get h, or the height of the tree, I need to cross multiply. I'm going to put a little 1 under here. Your favorite thing to do in math is cross multiply. So 20 times the tangent of 34 degrees is equal to the height of the tree. You just need your calculator now. So going to go into my calculator, and I'm going to type the 20 first, and then you go to trig and get tangent. Now I'm going to make sure I say something to you here. 34. Everybody look in that top corner. Make sure your calculator is in degree mode if you're doing this type of question. If it says RAD, you have to go into the settings and change it from radians into degrees. So double check that. So I'm just going to press enter. Oh, it didn't tell me the answer. Well, that's just wacky.
Hi, kids. Oh my God, both of us are the same thing. Look what she drinks. Water. I got to train this young one. All right.
No. I need to sleep. Thank you very much. Okay, so I fixed it. Mr. Krause actually had to fix it. So 13.49 is the height of our tree. So h is 13.49. Well, looking at my choices, it's rounding up to 13.5. All right. Okay, so which figure can have the same cross section as a sphere? A cross section is literally like cutting it. So if I cut something vertically or horizontally or diagonally, in any of these scenarios, will I get anything that's circular? So a sphere obviously is a circle, or well, like a ball, so a circular base really. I'm going to draw you a sphere over here. I'm going to make a circle and then a Santa belt and then a dotted, and then the center and radius. So there's my sphere. Which of these will have the same cross-section? Well, obviously choice 1 is all rectangles, so there's no way to get a circle. Choice 3 is rectangle, I'm not sure if they're square, and then triangle shapes. There's no way to get a circle out of there. But choice 2, if I cut it this way, I will get circular cross-sections in here. So it has to be choice 2. All right, so we've got this shipping container in the shape of a right rectangular prism with a length of 12 feet and a width of 8.5 feet and a height of 4 feet. Draw a picture. It will help your brain process all of the information that is being given to you. So to the best of your drawing abilities, and this is going to be fancy on here for me. Okay, so don't make it look square, by the way. If it says rectangular, make it look rectangular. So a right rectangular prism. How'd I do? Is that all right? So it says we've got a length of 12 feet, 8.5 feet for the width, and then 4 feet for the height. That's how you label those, right? The container is completely filled with contents that weigh, on average, 0.25 pounds per cubic foot. That's going to be important. What is the weight in pounds of the contents in the container? As soon as it mentions cubic feet, I know that that has to do with volume. I want to find the volume of this container. Volume of a rectangular prism is length times width times height. So I just have to multiply those numbers, 12 times 8.5 times 4. That's going to give me the total volume of this object. So 12 times 8.5 times 4 is 408. So 408 cubic feet. I think I have to click here. Equals 408 feet cubed. All right. Now they're telling me each one of those cubic feet weighs 0.25 pounds. So I have to multiply by 0.25 pounds. So back to the calculator. 408 times, so I'm just going to do times here, 0.25. 102 pounds. So 102. There we go, choice 3. Yay. All right. Let's see here. All right, so circles. Oh, I know how you feel about circles. So there are some fun facts that I'm going to write down for you that you need to make sure that you know before the geometry regents that are really important to your life. It gives you the circle A shown with, that's chords C, D, and E, F. All right, C, E, and F, D are drawn. Yay. Which statement is not always true? So the very first thing I'm kind of thinking about is some things inside those triangles. It's actually, I looked at it and I thought it was a circle question. This is actually a triangle question. So looking at these pictures, I hope that you know that anytime you see that crisscross angle business, that you have to mark that vertical angles are congruent every single time. Anytime you see an X in a geometry figure, those two angles are congruent. They're vertical angles. Now, it says which statement is not always true? Well, I'm going to try to mark some things first. What I need to know is that if I look at arc CD, or I'm sorry, ED, E to D, that arc is being held by DFE and by DCE, which means angles E and F are congruent because they're holding the same arc. And those angles are half of ED, if you wanted to know that. Okay? Then, if you look again, let me get my highlighter here. If you look at this arc, C to D this way, CDF, oops, hello, I went too far. Sorry. Let's erase that. Oh, I can never erase when I want to erase, right? Is that a thing? Oh, goodness gracious. Let's get just a new pen. Is this it? Okay. C to F, this arc, is held by CDF and it's also held by FEC. So that means angle E here and angle D here are also congruent because they're half of the arc. So I have all congruent angles. That doesn't mean congruent triangles. It means similar triangles. So similar triangles by angle, 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 right? Whoa, that was bad. Okay. And you actually only needed 2 angles, but that's okay. So which statement is not always true? Is CG, C to G, congruent to F to G? Do we say anything about sides being congruent? No, that's actually not true. So that's not always true. It's going to be choice 1. The rest of these have to do with sides being in proportion, triangles being similar, and angles being congruent, which is all similar triangles information. So choice 1 is actually your solution. Number 9, which equation represents a line that is perpendicular? If you see the word perpendicular, the very first thing you're supposed to pop into your brain is negative reciprocal slopes, negative reciprocal slopes, negative reciprocal slopes, meaning flip it and change the sign. So they give me this equation, but it's not in the y equals mx plus b form that I know dearly and love. So I'm going to move everything around. I'm actually going to cheat a little bit. I'm going to just add the y over and subtract the 7 over. I'm just going to flip-flop those. So 2x minus 7 is equal to positive y. The slope of this line is 2. So the perpendicular slope is flip it, 1 over 2, and change the sign. Which of these has a slope of negative 1/2? You don't even have to worry about the y-intercept. The only one with the negative 1/2 is choice 1, and it's over. All right, if this question made you think for a second, don't worry, it should. Which regular polygon has a minimum rotation of 45 degrees to carry the polygon onto itself? One of the most important words that you have in this question is the word regular. Regular means all sides and angles are congruent. So when we talk about an octagon, we're thinking a stop sign. A decagon has 10 sides. I should probably write these numbers here. Hexagon is 6 sides, and pentagon is 5 sides. And we're rotating, okay, rotating. So 45 degrees. I want to basically know, taking 360 degrees, which is 1 full turn, divided by what number, I'm going to call it n for number of sides, is equal to 45 degrees. So, favorite thing to do in math is cross multiply. 45n is equal to 360. Divide by 45. Whoa, my writing's getting out of control. So n is equal to, oh, where's my calculator? There it is. So we go 360 divided by 45 is 8. So it's an octagon. So go back to, well, back to here. Octagon is 8 sides, choice 1. Okay. So in the diagram of triangle ADC, below EB is parallel to DC. If they're parallel, put the little arrows for parallel. Okay, that's not a congruence symbol. A to E is 9, got it. E to D is 5, got it. A to B is 9.2, already there. What is the length of AC to the nearest tenth? So you actually have to, A to C. All right, so A to C is this whole side. You want to know this little guy right here. And I know your favorite letter to use in the whole wide world is X, so go ahead, call that X. We can set up a proportion using this triangle with the mid-segment, as long as they're parallel. We can set up a proportion here. So we can say that 9 on the left compares to the 5 on the left is equal to 9.2 on the right compares to X on the right. Cross multiply. 9x is equal to 46. Sorry, I'm not going to show that on the calculator. Divide by 9. X is equal to 5.1, which is fine. That's what x is equal to. So what is A to C? Notice that 5.1 is a choice. When you get x, that doesn't mean that's the answer. Look back at the question and make sure you've actually answered the question. We were finding AC. So 5.1 plus 9.2 is 14.3, which is choice 3. So I'm going to guess if you got that wrong, you picked choice 1. All right, in scalene triangle ABC, it says scalene. The measure of angle C is 90, okay. Which equation is always true? Oh my. This is a fun fact you have to know. It's called the complementary angle theorem. So, angle theorem. It says in a triangle, if you have, or in a right triangle, okay, the sine of A, the non-right angle, is equal to the cosine of the other angle. Vice versa is true. Cosine of A is equal to sine of B. It's also written as the sine of theta is equal to the cosine of 90 minus theta. Because these two angles, A and B, will add to 90 every time, because we've already used 90, there's 180 in a triangle. So that's why it says 90 minus theta over here. So let's see. Not that one, not that one. Cosine A, nope. Sine of A is equal to cosine of B. That's the complementary angle theorem. Whoops.